A direct proof in mathematics is just a valid argument in words that shows that a mathematical statement is tautologically true, given a certain set of assumptions. So, for example, we could claim that an odd plus an odd is an even. And of course, since we're doing mathematics, we have to be very particular about what these definitions are. So whenever we say an odd, we're meaning an odd integer, or a number from the set 1, -1, 3, -3, 5, -5, and so on. And by an even, we mean an even integer, which could be 0, 2, -2, 4, -4, 6, -6, and so on and so on. And you can do a quick check to see that this is true sometimes. So if we take 1 and 3, they're both odds, and 1 plus 3 equals 4, which is even. And also 5 and -5 are both odd, and -5 plus 5 is 0, which is even. However, you can't check all possible combinations by hand, because this goes off to infinity, and there's no way you can sit down, even for your entire life, and write down example after example. You'll never prove that always an odd plus an odd is an even. So we need some sort of argument. And to make an argument, we're going to write the set of odd numbers as the set of numbers x, such that x equals 2k plus 1 for an integer k. So an odd is always twice a number plus 1. And you can check this, so 5 is 2 times 2 plus 1, and -7 is 2 times -4 plus 1. And similarly, the set of evens is 2 times a number, so an even number is divisible by 2. And therefore you can write it as 2 times something, so 6 is 2 times 3, and 0 is 2 times 0. So if we have two odd numbers, a and b, then there must exist some numbers c and d such that a is 2c plus 1, and b is 2d plus 1. That's just from the fact that a is odd and b is odd. So now use substitution. A plus b could be written as 2c plus 1 plus 2d plus 1. And then rearranging the formula, we could write this as c plus d plus 1 all times 2, just by combining the like terms and factoring out a 2. And this is a number. If we box the whole thing, we could write an x over it, and it's just like 2 times x, which means it must be an even number, because it's 2 times an integer. And therefore, any odd plus any odd, since we took two odds in general and added them together, must give us an even, since we got an even. So that's an example of what a direct proof looks like. And we have all sorts of different kinds of claims that might need to be proved, and we might call them a claim, a lemma, a corollary, or a theorem. And so what you're going to see is something like lemma, such and such statement, or claim, such and such statement, followed by either proof or possibly counterexample. And a counterexample is a way to falsify such a claim.